Hello guys, welcome to the fourth video in the series on object-oriented programming using C++, and in this video we'll be talking about data types and variables. So what is data type? Data type tells the compiler about how the programmer is intending to use the value, whether they intend to use it as an integer or as a real number or something else. It also defines the operations that can be performed on the data. For example, we can multiply two numbers but we cannot multiply two strings, so the operations are clearly defined by the language. It also tells the compiler how the data is to be stored. This is necessary because different data types require different amount of storage in the main memory. Say, for storing integer value, we require 2 to 4 bytes, whereas for storing character value, we require 1 byte. It also provides a set of values that the data can have. Say, for character data type, we can have alphabets as the value, and for the integer data type, we can have positive integers, negative integers, and 0. We will discuss about sizes and ranges of each data type in an upcoming slide. This diagram might seem familiar to you because we have already seen this in the previous video. Data types in C++ are categorized in three types: built-in data types, user-defined data types, and derived types. Built-in types. These are ones provided by the language directly. These include the simple types such as character, integer, and floating point types, and the Boolean type. User-defined data types. These are types which are created by the programmer and are constructed using different built-in data types. These include things like enum, structure, union, and classes. Derived data types. These are types which are derived from built-in data types. These are aggregations of simple types, like integer array is used to store a bunch of integer values. In this video, we'll be learning mostly about built-in types, and as the series progresses, we'll talk about other types as well. Let us now talk about built-in data types. These are predefined by the language as we have already seen, and these are used to declare variables which are used to store value. Let's start with integer type, that is int, which is used to store integer values. Character type or the char is used to store character values. Boolean data type is used to store Boolean values and is very much used in conditional statements or looping structures. Floating point type or the float is used to store single precision floating point values. Single precision means it occupies 32 bits or 4 bytes. Double is also used to store real numbers like float, but they have double precision means it occupies 64 bits or 8 bytes. As size of double is large, it can take on more values and is used to perform more exact calculations. Void is used to represent the absence of value. It is mostly used to show that the function is not returning any value. Wide data type is similar to character data type, but it takes up twice the space and can take on much larger values as a result. It is used to encode characters for virtually all languages, whereas char data type can only encode English language characters. Wide data type is very rarely used. Now, let's have a look on the size and range of values that basic data types can have. Int takes 2 or 4 bytes depending on the compiler and processor you are using. Integer can take negative and positive values, but if you want to store only positive values, you can use unsigned int. Integer takes values from -32768 to +32767. But what if you want to store values larger than this? You need to use long int, which occupies 4 or 8 bytes. Even then, if you are unable to fill in your desired value, you can use long int. These long, short, signed and unsigned are known as modifiers to yield further simple types. Double takes 8 bytes as we have already seen due to it storing double precision values. We can have long double to have a storage capacity of 10 bytes. Char takes 1 byte for its storage. Similarly, we have signed and unsigned char. If you are wondering how these values have such ranges, you can use these formulas to calculate these values yourselves. For signed data types, we have values from -2 raised to n minus 1 to +2 raised to n minus 1 minus 1. And for unsigned data types, we have values from 2 raised to n minus 1, where n is the number of bits. Coming to the second topic of the tutorial, variables. Variable can be considered as the fundamental of all concepts in C++. We store values in the variables for later use. You can think of variables as a small box where you can store values. Variables need to be declared before their first use. As you can see, we can declare variables in this fashion where you mention the data type and you mention the variable name. For example, we are declaring variable x of type integer and we are providing the value 1 to the variable x. This int x is known as declaration, whereas assigning a value to the variable is known as definition. In declaration, we are informing the compiler about the name of the variable and the type of data it will hold, whereas in definition, we are assigning the value. We can combine the declaration and definition of the variables and write it as int x equals to 1. As you can see here, the variable x is stored at location 100 in the main memory. Whenever you ask for value of x, the program returns you with the value stored at location 100. Thus, variable can be thought of just a label for the memory location. Let's write a program to add two numbers. I'll declare the first number as integer and I'll assign a value 10 to the variable a. Here we are declaring and defining in two different steps. We can combine them as we have seen. I'll declare the variable b and assign it value 20. I'll use a variable c to store the sum of a and b. Now I'll print the contents of c, that is the sum of variable a and b, to the screen. If I want to know the number of bytes that integer is using for its storage, I can use the size of function. We have also seen that variable names are just labels for the memory location. What if I want to know the memory location of the variable a? I can use the ampersand symbol followed by the variable name to know the memory location of the variable. I will save and I'll execute it. As you can see, the sum of a and b is 30 as we expected, and the size of integer on my machine is 4 bytes or 32 bits, and location of variable a is mentioned over here. It need not be the same on your machine. Please like and share this video with your friends. Also, subscribe to my channel if you haven't. Stay home, stay safe, and thank you.